All right, guys, Mr. Antonucci here, and in this video, we're going to talk about classification of ordinary differential equations, and we're going to do three different learning objectives. This first one, we're just going to talk briefly about classifying ordinary differential equations, and what they are an equation involving an independent variable x and a dependent variable y, and derivatives of y with respect to x. So here on the screen, we have listed several different ordinary differential equations. Um, some differential equations contain derivatives in different orders. For example, equation C has y double prime and y prime. The highest order derivative that appears in a differential equation is actually referred to as the order of the differential equation. So A, B, and F would be considered first order differential equations because their highest derivative is the first derivative. Equations C and E are second order. Again, highest derivative is the second derivative. And D is a third order differential equation, again, because the highest degree is the third order there. So the next thing we want to do is look at an example where we just identify the order and degree of the differential equation here. So if you look at this one, the um, the highest derivative is the second derivative. So this would be a second order differential equation. And it would be first degree because the exponent of the highest order derivative in the differential equation is called the degree. Okay, so that would be a first order differential equation. All right, now the second thing we want to talk about is how to verify solutions for a differential equation. So in this one, we have a situation where we have to verify differential equations. So we want to verify that f of x equals x to the fourth minus 5x plus 1 is a solution to the differential equation y double prime minus 12x squared equals 0. So first thing you do is you take, so this is for part A here. You take the derivative of y, which is 4x cubed minus 5. And since this differential equation, the highest derivative is the second derivative, we're going to take the second derivative, which is 12x squared. Okay. And then if the differential equation is y double prime minus 12x squared equals 0, then we can take this 12x squared for y double prime and substitute it in, and then solve the equation, and it should work. Just like how we substituted values for variables, here we're substituting the derivatives in for the notation of the derivative and showing that it in fact works. If we go to equation B, g of x is x to the fourth plus c1x plus c2, where C1 and C2 are both constants. So again, since we're looking at the same differential equation with y double prime, we have to get the first derivative, which would be 4x cubed plus C1, because C1 stands for a constant, and so C2, the derivative of that would just be 0. And then the second derivative here is 12x squared. Similar thing, we're substituting it into the equation y double prime minus 12x squared equals 0. So when we substitute that in, you end up getting 0 equals 0. So the equation is satisfied. Notice that it doesn't matter what C1 and C2 are, they can be any numbers. So basically, this is showing that there's an infinite number of solutions to this differential equation for different values of C1 and C2, as long as you have x and then just a constant there for that one. Okay. So next thing we want to do is look at this differential equation here and verify that the equation x squared minus x cubed y plus 3y to the fourth equals c is a solution to this differential equation right here. So sometimes all you have to do is differentiate, solve for dy dx, and you're good there. You'll see this type of question with implicit differentiation on free response questions often on the AP exam, where they actually give you the solution like this, and you just have to show that the equation they give you is that. And then they'll have more things to do, but that's kind of setting you up there. So if I have x squared minus x cubed y plus 3y to the fourth equals c, um, and I take the derivative with respect to x of all of that, derivative of x squared is 2x minus the derivative of x cubed y, we'd have to use the product rule. So the derivative of the first would be minus 3x squared y minus x cubed times dy dx plus the derivative of 3y to the fourth would be 12y cubed times dy dx. And remember, when we differentiate implicitly, you want all your terms with dy dx on one side, all the other terms on the other, factor out your dy dx and solve for dy dx. Okay, so this is going to equal 0 because the derivative of a constant is 0. Okay, so we would have dy dx. So I'm going to factor it out of these two terms here and rewrite it as 12y cubed minus x cubed, and then put these two terms on the other side. So it'd be 3x squared y minus 2x, and then solve for dy dx. Just divide by that quantity. So 3x squared y minus 2x all over 12y cubed minus x cubed. Okay, so that function defined by this equation satisfies the first order differential equation. So it's a solution for that one there. Okay. Now, sometimes what happens is whenever you solve for dy dx, you might get the opposite in the numerator or denominator, something like that, because maybe you solved on the right side instead of the left side for dy dx. Just make sure everything works out there. So the third thing we want to talk about is finding the general solution and a particular solution of a differential equation. So we'll start with an example here. So a couple pieces of terminology are boundary condition, or an initial condition is a restriction on the variables of the general solution that leads to a particular solution. So here, if we want to find the general solution to this differential equation, the general solution, it consists of all antiderivatives of 6x squared plus 5. So if we just integrate that, we get y equals 6x squared plus 5 dx, the antiderivative, which is x cubed over 3 multiplies the 6 gives us 2 plus 5x plus c. This would be considered the general solution. So I'll just write it y equals 2x cubed plus 5x plus c, because it has the general constant of integration there. So that's the answer to part A. For part B, now we have the constraints on it. So we have the initial condition of x equals 1 and y equals 10. So I can substitute 10 in for y and 1 in for x, like so, and then solve for c. So you get 10 equals 7 plus c, so c equals 3. And one of the things I often see students do is they'll stop right here at this step, because kind of like we got an answer, we got the value of c. But if we're asked for the particular solution, that is asking us to write the function that is represented here. Okay, so we would have y equals 2x cubed plus 5x plus 3, and that is the particular solution using the initial conditions there. All right, we got one more quick example we want to go over. Same kind of thing, find the general and particular solutions here. So with this one, if we have dy dx equals e to the x plus 4 sine 2x, then y is going to be the antiderivative of e to the x plus 4 sine 2x plus dx. If I anti-differentiate, e to the x is e to the x. The antiderivative of sine of 2x is negative cosine 2x. And to reverse the chain rule, you'd have to have a factor of 1/2 here, plus, well, not plus, but and the factor of 4 multiplied. So we have our plus c. So this would give us y equals e to the x minus 2 cosine of 2x plus c. All right, and that is our general solution. So for part B, we're going to use the point 0, 4. Okay, x equals 4, y equals, or x equals 0, y equals 4. They might tell it to you like that. They might give it to you in a point. They might give it to you in function notation, f of 0 equals 4. All three of those are different ways to communicate the same idea. And the same procedure is going to follow for figuring out this one. We're going to substitute 4 in for y and 0 in for x. So 4 equals e to the 0 minus 2 cosine of 2 times 0, which is cosine of 0 plus c. So 4 equals e to the 0 is 1. Be careful there. Lots of times students will make that just 0. Minus cosine of 0 is 1. So 2 times that would be minus 2 plus c. So we have 4 equals negative 1 plus c. So c equals 5. Again, write the particular solution. Y equals e to the x minus 2 cosine 2x plus 5. All right. Well, that's it for this one, guys. Hope that was helpful to you. Reach out if you have any questions. Take care.